Starting next week, we're going to be looking at confidence intervals. And this is going to be an important one to come back to. And notice it just gives you a very general equation. This doesn't have any notation at all. It's just actual words written in. The reason for that, and don't worry about the chi-square, we haven't even got to that yet. But when we look at the next page, these are the things that we will be, and you might want to kind of flip back and forth. Our statistic, parameter, standard error, critical value, well, not the critical value, we'll talk about where that comes from. But these other things are going to come from this side of the page. So we're going to have, and this is where I was telling you that the first thing you're going to want to figure out is, are we looking at proportions or means? And notice that they have it broken down right here, proportions and means. So as soon as you identify what the problem is all about, we can just automatically jump to that. So let's say we saw a lot of problems yesterday where we were dealing with proportions. So I just want to completely ignore that box. I don't need to know it. All right. And then we haven't learned about two populations yet, so we can ignore that one. So let's say we've determined its proportions. We've got only one population. And now the only other thing, what we're typically going to be looking at moving forward is not even this value, but this one right here. But again, that's putting the cart a little bit ahead of the horse. We haven't talked about that yet, but I just want to tell you, there's not much difference between these two. If you look at that, it looks like just a quick glance, you're like, oh, it's two different equations. Well, not really. Look at the difference between this and this. We're either using p hat on the right or p. The difference being, this is our sample proportion. This is the population proportion. So it's essentially the same formula, and we'll talk about why we would use one versus the other. But notice all of these are essentially the same thing. There's a little bit more confusion right here when we are dealing with, because these two essentially are the same. But I should point out that this formula right here, that one is a little different, and we will, again, get into all that. But that's for two populations. That's not coming up for at least a little bit of time. So there we've got it. If I tell you that, as you're talking to yourself through a problem, you're saying, okay, this is proportions. There's only one proportion here. I'm comparing it to, here's a sample that I'm comparing to a population proportion. So now you can figure out what your sampling distribution is going to look like. And you can figure out your standard deviation by pulling up that. And you can pull up your mean by using that formula. So I kind of recite it from memory sometimes, and I'll just say, oh, remember your standard deviation for a sampling distribution of sample proportions is just p times 1 minus p all over n. You see me write that a number of times. I'm getting it from right there. So now you can identify where to find it, and understand that there's a logic to the formula sheet. So I've already said this, but when we decide from the beginning that it's proportions, I'm going to be looking right here, and I'm going to be able to find that formula somewhere in that box. Okay. And a lot of this is just knowing the notation. So if you can tell yourself, this question is asking me for the standard deviation of a sampling distribution of sample means, and there's only one population, then you can narrow it down right there. I know it's means, I know it's one population, and they're asking for the standard deviation. So there's my formula. All right. And so we had some problems like that the other day. And so what I was going to do is I was going to, we're not going to look at this linear regression. This is literally the last unit that we talk about. And we'll be able to cover it, but it's really not, if that looks complicated, it isn't that complicated in practice based on what AP expects of us. Now, the rest of the formula sheet, we typically don't use the Z tables or the table A right here. This is what you can do if you want to figure out the area of the tail by hand. You can do that. And it's, honestly, we don't use them because we have technology for it. So if you really want to use these tables, we can talk about it, but I'm not going to take class time to do that. Notice that these tables only go from 3.4 z-score down to a negative 3.4, which is plenty, you're pretty much never going to have anything above or below those values. Okay, this is one that we're going to be introducing before too long, the t-table, and you don't need to worry yourself with it right now. Just understand that it looks like it's the same thing, but there is a difference that we'll talk about. And this chi-square critical value, if that, here's the good thing about it. I don't know if you feel the same way, but it's, what am I trying to say? This looks complicated perhaps, but then you're going to understand it. You're going to realize it's not so complicated, and you're going to feel like way smarter than the rest of the population that will look at this and be freaked out by it. So look forward to that. Okay. So that's your formula sheet. And just the last thing I wanted to do was pull up the same problems we were looking at yesterday without actually going through them. I wanted to look at, here we go. So this problem right here, I think, actually this one right here I wanted to look at. So when it was looking at this problem, they're saying, okay, so what is the probability? And we had these, the probability of having a particular outcome happen. I'm not going to go through the scenario. We looked at it yesterday. But this was essentially, I was talking about, this is essentially your z-score. And notice that we decided right off the bat that this was dealing with proportions. Okay, and so does it ever say the word proportion? I don't know that I can see it. But you can decide if this is proportions or means, and it's not hard to figure out because we're dealing with, this phrase right here, 22% of children in the United States, ... That's a proportion of children in the United States. So we are dealing with proportions. So we're going to be looking at the sampling distribution of this. So immediately when you notice proportions, you can be thinking sampling distributions. This is a mean of p hat, the sampling distribution of sample proportions, and this. So now, if I jump over, and you guys can do this, but if you jump over to the AP formula sheet, if you can narrow it down right away, saying it's proportions, it's sampling distributions. I'll just pull this up real quick. Hold up. That's where we're jumping over to these formulas right there. And so you don't have to think about it that hard. You have to think about it enough to know where to find your formulas. Okay, and oh my gosh, let me pause real quick. So to pick up where we left off after that webinar, again, just the purpose of today is to see how this applies when it comes to the AP formula sheet and these types of problems, but not just these types. It's going to be important to. It's going to be important to be able to go. Not me, is it? No. Okay, you got it taken care of. All right. It's just going to be important to know how to navigate your way through that formula sheet. And so I think there was one more that I was like this one right here. This is one that it's a conceptual question, but I still want to come back to it. And we already did answer this, but just to figure out how you're going to navigate through the formula sheet to do this, it says we have a pair of sample size and population proportion, and we want to find the greatest standard deviation for a sampling distribution of sample proportion p hat. So this is already telling you where to navigate to. Sampling distribution of sample proportion p hat, and we want to get the standard deviation. So it's going to be, I'm going to go ahead and write the formula down, but then I'm going to show you how we navigate over there and find it. You guys could probably do that right now anyway. But it's going to be standard deviation for a sampling proportion, a sampling distribution of sample proportion p hat. So that's what I'm looking for. Okay? And when I do that, I'm going to find it's p times 1 minus p divided by the square root of n. I'm not going to go through the conceptual part and answer. We already figured out what that one was yesterday. But if I switch back over to this, then sure enough, right here is that very formula that I was just referring to. So the sooner you can familiarize yourself with this, navigate your way through it effectively and quickly, the more confident you're going to be with all these problems, and the easier it's going to be. Okay. So with that, that's like I said, I wanted to make it kind of a chill day. We're not going to go through more of these problems, but I'll stick around if there are other ones of these you looked at and you did have questions about. So we can certainly do that, but I will call this a day for those of you who are ready to sign off and be done with it. So anyways, have a great weekend. I will see you on Monday. And yeah, that's it.